Good morning, everybody, and welcome. And thank you for coming on a Saturday morning at 9 a.m. to a session about encryption. So, yeah, really appreciate that you're here. I'm going to talk about confidential software development with Always Encrypted using enclaves. So my name is Peter. I'm a program manager in the data platform security team at Microsoft. So that's the team that manages all the security features in Azure SQL and SQL Server. And I'm the program manager for two features. One is called Ledger, where we're not going to talk about today, and the other one is Always Encrypted. I've built this presentation with my colleague Michael. He's not here, but the software that we're going to use, so the little application that we created, he helped me with that. So just, yeah, that's why I put him on the welcome slide. All right, so for questions, I will pause from time to time. If you have any questions, let me know. If I go too fast, let me know. If you don't understand, also let me know. All right, so what's the goal of today? First of all, it's going to be two parts. First part, I'm going to explain what Always Encrypted is, how you can implement it in Azure SQL, and then the second part will be writing the code, right? What will break in your application when you start using Always Encrypted, right? And I'm going to explain also, of course, how you can resolve these issues. All right. Let's get started with Always Encrypted. So what was our motivation? We wanted to help our customers to protect their most sensitive data in the cloud, like credit card numbers, social security numbers, and stuff like that. But on the other hand, we also wanted to keep the customers to be in control of their data, right? And to give you an example, we wanted to have their sensitive data protected from high-privileged users. And to give you an example, in my previous job, I was a customer engineer, so I went to lots of customers, and I could easily do select star from a specific table, and I could see literally everything, right? But sometimes, there is sensitive information in that table, and you don't want to expose that to external users, to DBAs, for example, to operating system administrators. So you want to protect that data from malicious insiders. So that's why we came up with a technology called, called Always Encrypted. And it's really a column-level encryption technology. So we started our journey in SQL Server 2016. So that was the first version that we released back then. And it's called Always Encrypted, right? It is available still in SQL 2022, and we have it also available in Azure SQL Database and also in Cosmos DB. So how does Always Encrypted work? Let me show you this on the, I need to get my laser pointer here. All right, so this box here is the application, and that is considered as trusted. So everything that happens inside the application, the data can be exposed. Everything outside the database, so the network, the database engine, the DBA, the external persons, they are considered as non-trusted, right? So it's really a client-side encryption technology, which means that the client driver of your application is doing all the work. So let's assume that your application requests information to SQL Server. So what they're going to do, we're going to send a query in plain text. The client driver is going to convert that plain text into ciphertext, and it's going to be sent in ciphertext over the network to the database engine. The database engine knows about this encrypted value, and is going to send back the encrypted information back to the application. The client driver receives that information, and it's going to decrypt it, and it's going to show it to you in plain text inside your application. So as long as you have access to the encryption key, you will be able to see the data. If you don't have access, you will not see any information inside your application or even outside the application. Make sense? So it's really the client driver that's doing all the work here. Now, with this first version, that was good, but you were quite limited in functionality. And what I mean by that is, if you wanted to use an encrypted column in a where clause, for example, the only option you could do was where field equals a specific value. You could only use equality. So there was no way you could use larger than, smaller than. That was not possible. You could not use joins, for example. That was not possible. You could not do order by on an encrypted column. So you were quite limited in functionality. So what we wanted to address this problem, and we came up with a second version of Always Encrypted, which is a better and a more advanced version. That's what we call Always Encrypted with secure enclaves. It is available in SQL 2019 and 2022, and it's also available in Azure SQL Database, not yet in managed instance. So the principle is completely the same. So we again have our client application with the driver, but now we also have inside the database engine what we call a secure enclave. And a secure enclave is really a protected memory environment inside your server or inside your database. Nobody has access to that specific piece of memory. So what does it mean is that when the database engine needs to do computations on encrypted data, excuse me, it's going to delegate that computation to that enclave. So we can then safely decrypt that information inside the enclave and then do the computation. So this means by leveraging the enclave, we can now do what we call rich confidential queries. You can now do larger than, smaller than on an encrypted column. You can use like on an encrypted column. You can do ordered by. You can even create an index on an encrypted column. So you get much, much more flexibility by using this Always Encrypted version with secure enclaves. On top of that, you can also use what we call in-place encryption. So let's assume that you want to do an initial encryption on a column. In the first version, what we had to do is we had to extract all the data outside of the database to the application, do the encryption there, and then push it back in. So that was slow and was not really secure because, yeah, we need to extract all the data. With the enclaves, we don't need to do that. So the data can still stay inside of the database. We're just using the enclave to do the initial encryption. So much more secure and much faster. Same for key rotation. If you want to do key rotation, the data doesn't have to be moved out of the database. Make sense? Everybody still with me on a Saturday morning? Cool, great. All right. Now, what is an enclave? I already explained it's an isolated region of memory inside your server that can be used to safely decrypt information. Now, how can we make sure that that enclave is secure? And there are two ways to do that. So you can do it by using a specific hardware, and that's what we call an Intel SGX or Intel Software Guarded Extension. So that's really a physical CPU that is used in the server to secure that enclave. That's the first way to do it. The other way is using a software-based, what we call virtualization-based security, or VBS enclaves, right? It's a Windows setting that is available in Windows Server 2019 and higher, or Windows 10 and higher. So you have the choice, right? Now, what is the difference? If we look at, excuse me, secure enclaves in Azure SQL Database, you have both of the options. So you can choose between Intel SGX enclave or VBS enclaves. If you want to use Intel SGX, you need to configure a specific type of database called the DC series. So you will see that in the portal. And when you configure that, under the covers, we're going to create a virtual machine for you with that specific Intel SGX CPU, right? For VBS enclaves, you don't need any specific hardware, so you can choose whatever database you like. It's just a setting that you need to switch on, like, hey, I want to use an enclave. I want to use VBS enclaves. Easy peasy. What's the difference between the two? So for Intel SGX, it's only available in vCore model. You can go up to 40 physical vCores compared to VBS, where you can go up to a limitation of, excuse me again, 128 vCores. That 40 vCores is already a good improvement because last year we were limited to 8 vCores. So we increased that. We are using new hardware under the covers, so we can now go up to 40 physical vCores. Region availability, SGX enclaves are quite limited in the number of regions because we need to have that specific hardware. So it's available in East and West US, North and West Europe, Canada Central, UK South, and Southeast Asia. If you need it in another region, let me know. I can enable more regions for you, but you need to have a good use case. Otherwise, we won't spend money on new hardware in that region. But if you need it, let me know. For VBS enclaves, it's available in all different regions. Now, where's the difference between the two? When should you choose Intel SGX, or when do you want to choose VBS, virtualization-based enclaves? Well, the difference is, in encryption is exactly the same, but VBS enclaves do not protect you from attacks from the host OS, which means, maybe bluntly said, but if you do not trust Microsoft, don't use VBS enclaves. Use Intel SGX enclaves, right? It all depends on from who you want to protect your data. If you're saying, I just want to protect data from the DBAs and some internal people, fine, then you can use VBS enclaves. If you're saying, no, I want to protect my data from everybody, including Microsoft, fine, or including your host operator, then you have to go for Intel SGX, because then there's no way we can get to your data, right? So I have customers, they have that requirement, so they're all using Intel SGX. Okay, let me pause it for a second. Any questions? No. Means that my explanation is good then. Okay. A little bit more about enclave attestation. So that's an extra service that you need to configure if you're using Intel SGX as well. So you need to make sure that nobody has actually tampered with that enclave, right? So you need to be able to verify that, and that is done by an attestation service. And in Azure, we have a service called Microsoft Azure Attestation. So if you want to use Intel SGX, you will need to create, it's a SaaS service, so you just need to create a resource of Microsoft Azure Attestation and then configure an attestation policy. This is a screenshot of a policy. This is completely documented in our documentation how to do that. It's fairly easy to do. And with that attestation, so the application and the database will then be able to verify whether your enclave can be fully trusted. For VBS enclaves, we currently don't have attestation. We don't support it yet. We're working on that. So there is no attestation there. All right, a little bit more about the two encryption methodologies. If you want to encrypt a column, there are two ways to do that. You can choose between randomized or deterministic. Now, what's the difference between the two is, let's assume we have a column name, and there are multiple Peters in that column. If you choose deterministic, the encrypted value will be exactly the same. So if all the Peters will have the same encrypted value. If you choose randomized, then even though the value Peters are the same, the encrypted value will be different, right? Which makes randomized more, or is a stronger encryption compared to deterministic, yeah? If you want to use Always Encrypted with secure enclaves, you have to use randomized. You cannot use deterministic. If you're still using the first version, Always Encrypted, then you can choose between then you can choose between deterministic or randomized. There's no, yeah, but I would recommend to use randomized and not deterministic. All right? Cool. One last thing before we jump into a demo. What are the roles and responsibilities when you start implementing Always Encrypted? And yeah, maybe this is for larger companies, but again, it all depends from who you want to protect your data. And in this case, I see three types of peoples or roles or responsibility. And the first one is the DBA. The DBA shouldn't have access to the keys. They're not allowed to see that sensitive information, but they still need to do, or need to be able to work inside the database. So what is their role in implementing Always Encrypted is, yeah, they need to configure the database with an enclave, so or Intel SGX or VBS, and they can manage the metadata of the keys inside the database. So we're never storing the encryption keys inside the database. It's just metadata that is pointing to the key, for example, in a key vault or in a Windows certificate store, right? If you give access to the encryption keys to the DBA, yeah, then the whole principle of Always Encrypted falls down, right? Because they have access then to all the data. So it depends. If you trust your DBA, then you can give them access, but I wouldn't recommend to do that. The second role is a security officer. That's the person that generates your encryption keys and that manages the keys also inside your key vault. Or if you have another key store available on premises, that is also a possibility. And then the last role is the developer or the application user. They should encrypt the columns, they should configure the application to use Always Encrypted in the connection string. Come back to that in the second part of this presentation. And then they need to write code that take advantage of Always Encrypted. All right? So these are the 3 parties that you have to be aware of. This is also documented in our documentation. A small example, perhaps a little bit technical, so all be awake, I would say. Again, the left side here is the client side, trusted. The right side is my Azure SQL. So how does it work? In your code, when you're doing a select statement, for example, select name and social security number from customers, where social security number equals a specific value, 111, 22, and so on. Let's assume that social security number is the encrypted column here. So what happens? The client driver, before we're sending the real query to the database, we're first going to execute a stored procedure. It's called SP describe parameter encryption, because the application needs to know which columns are encrypted inside that specific database and inside that specific table. SQL execute that store procedure, and it's returning metadata to the driver. And inside that metadata, what we're mentioning there is what are the encryption keys, where are they located, and what are the columns that are encrypted. So just hold on. So once the client driver receives that information, it knows where the keys are stored, so it can try and connect to that specific key. Now, normally, your application should have access to that key, and then it's going to resend the same query again, but now with the encrypted information, because it knows that the social security number is encrypted. The SQL engine is returning the information, so the name, Jim Gray, and the social security number, again, in ciphertext. And then your client driver is going to decrypt it and is going to show the social security number in plain text on your screen. So this is pretty simplified how it works for Always Encrypted. You had a question?
So if you have a really chatty application, then the driver becomes a bottleneck, I think. Is there any noticeable performance overhead?
Yeah. I will repeat your question. So the question was, is there an overhead when using Always Encrypted? There is, yeah. So because, well, the first query, so that stored procedure, it's just one time that we need to do, because then it is cached, so there is only one turnaround that we need to do. But yeah, every single time the client driver needs to decrypt and encrypt your information. So there is definitely an impact on performance. How much? I don't know. It depends always on SQL, of course, how many data you're encrypting, how many columns you have, what is your load? Is it the typical update load, or is it a more readable load? So it all depends, but you need to test. But I can assure you there is definitely a performance impact. Yeah. All right. Other questions? No? Okay. Let's jump into a demo. So what I'm going to do is I'm using a simple web application that contains sensitive information, and I'm going to encrypt that information in real time. So it's not a recording. I'm doing it live for you, so hopefully all goes well. All right, so let me first jump to the portal. What are the resources that I'm using here? Is this readable in the back there, sir? Okay, or I can make it bigger if you want. All right. Cool. So what do I have? I have my database called Contoso HR that contains all the information. I have my web application. That is my web application here. So as you can see, it is used by an HR department, and it has quite sensitive information. So security number, first name, last name, and salary. I can search in that application, and then, for example, it will show you all the social security numbers that contain 999, for example. What else do we have is the key vault. So I'm using Azure Key Vault to store my encryption keys. If I go to the keys, I have one key here, which is the column master key. I'll come back to it immediately. So this is the key that I'm going to use to do the encryption. Now, you need to have permissions, as I explained, to decrypt that information. So you can choose, in Azure Key Vault, you can choose between policies, but we do not recommend to use policies anymore. The recommendation is to use the RBAC permissions. And what access do you need to have? So you need to have read, list, and decrypt. But what I recommend is that you give your user or make it part of the role Key Vault crypto user. And then you will have the appropriate permissions to do all that, doing the list of the keys, doing the reads of the keys, and so on. Yeah. So my account has that, has these permissions, but also the managed identity of my application has permissions on the same key, because the application also needs to be able to decrypt that information. Make sense? Okay. So let's jump into the Management Studio now. The first thing that you need to do in your database, so this is my Contoso database, and I just have one single table called employees. Under security, you need to configure your encryption keys. So you have the column master key, and then you have the column encryption key. So the column master key is actually the metadata that is pointing to the key inside the key vault in my case. So let me show you. Properties. There we go. So here in the keypad, you can actually see that I'm pointing to my key vault /keys /CMK. So that is the key that I'm going to use for the encryption. Once you've configured your encryption key, your column master key, you need to configure a column encryption key. And the column encryption key is encrypted by the column master key, and the column encryption key is then used to encrypt your columns. Make sense? All right. So once you have your keys, then you need to start the encryption. There are several ways to do an initial encryption. You can use T-SQL, you can use PowerShell, but we also have a wizard in the Management Studio. I don't know if you've ever seen that, but here we have the option encrypt columns, right? And that is always encrypted. So if let's use the wizard. So you get a welcome screen. First step is you need to select the fields that you would like to encrypt. So I'm going to encrypt social security number and salary. And here you need to specify the encryption type. Now I want to use my enclave. So as I explained, you need to choose randomized here in this case. So randomized. There's no need to configure a new master key because I already have one. In place encryption, yes, and here you need to specify that attestation protocol that I mentioned. In this case, I'm using VBS enclaves, so I'm not, attestation is not supported, so you need to select none here. Run, just a summary, and as you can see here below, I'm actually using in-place encryption, right? So because I'm using the enclave. So click finish, and this will just take a couple of seconds to do the initial encryption. In the meantime, if there are questions, let me know. No? Okay.
If you use this on-prem, would you then also still recommend storing those keys in Key Vault?
Yeah, so the question is, if you're using it on-prem, do you recommend to store it in Key Vault? You can. The options that you have is Key Vault or Windows Certificate Store, or if you have your own key store on-prem, sometimes that happens, that is also a possibility. So there are choices, yeah. There's not, yeah. We recommend to use Key Vault, of course, but if you have another possibility, why not? Okay? All right, so in the meantime, the encryption is done, which means I have here a couple of query windows open. The first one here, if you look down, I'm connected with my own account, and as we have seen, I have permissions on the key. So if I run this specific query here, select from employees, I can still see the same data like on the website, which is normal because I have the encryption keys, or I have access to the encryption key. This query window here, I'm logged in as Azure admin, which is DBA login, which doesn't have access to the encryption key. So I can still connect to the table, and I can still run queries here. But as you can see now, social security number and salary is completely in ciphertext. Why? That account, Azure admin, doesn't have access to the encryption keys. If I go back to my application, I just need to clear the cache because it needs to refresh, because now now I have encrypted it. So if I just do a refresh here in my application, I can still see the plain text information. Makes sense? Because also my application has the same access to the keys. I can still filter. If I go back here to my query window, I can use now these rich confidential queries. So for example, here I'm using social security number like, right? If I do this, it will just filter out an encrypted call. Compared to always encrypted, this would not have been possible. The same for salary, larger than, smaller than, this will not be possible. Cool, huh? Yes, sir. The question is if you can search the encrypted value. No, you cannot. You cannot. So the type of the encryption will be changed. Well, the data type will be exactly the same, but we will change the collation to binary collation. Yeah. Yes, sir.
Sorry, just to clarify that question. The encryption text, yes, you can set the value. With this having to be randomized, you can't.
Yeah, okay. Fair point. Yeah. Other questions? No? All right, cool. How are we doing on time? We're doing good. Perfect. Let me go back to my presentation. So that was the first part. How does Always Encrypted work and how you can configure. As you have seen, not that difficult to do, I would say. Okay, second part is what happens in your code, or what do you need to do on an application site to make it work? Because out of the box, I can assure you it will not work, your application. So you will need to do some stuff. And the first thing that you need to do is you need to upgrade your drivers, because all drivers do not support Always Encrypted. If you're using .NET platform, you have to go for .NET Framework 4.6 or higher, or .NET Core 2.1. If you're using the other drivers that we support are ODBC, GDBC, and PHP, so no OLEDB. We're not supporting that. If you want to use Always Encrypted, so the first version, you have to use version 13.1. If you want to use enclaves, you need to upgrade to 17.4, or if you want to use VBS enclaves without attestation, then you need to go for version 18.1, right? So for GDBC, it's 6.0 or 8.2 or 12.2 if you want to use VBS enclaves. All right? That's the first step that you need to do. Upgrade your drivers. Okay? Now, if you want to write or starting the code, and I'm using .NET here, what are the assemblies that you need to use? So you need to use the Azure Core, Azure Identity, because we need to be able to connect to our Key Vault. Then we also have the Key Vault secrets, if you're using, or if you're pulling the connection string from the Key Vault, which I'm not going to do in my application. And then, of course, the Data SQL client and the Always Encrypted Key Vault provider. So these are the assemblies that are needed. So what are the steps that you need to do in your application? So first one, you need to connect to Azure, because we need to be able to connect to our database that is stored there and to the Key Vault. So that's the first step. Secondly, get or build your connection string to connect to the database. Then, of course, you need to connect to the database, and then you can start running your queries. But that's probably something you all know. Okay, before I continue with the slides, let's already jump into a demo. So we have built a simple application, and I'm going to show you what issues you can hit. Okay? All right. So this is the application that I'm using. It's written in C#, and it's using the same database that I've used in the previous demo, so we know that the columns are encrypted. Now, if I run this for the first time, without changing anything, so I'm connecting to Azure. Here below you can see, okay, I'm running select top 10 social security number, salary, and stuff like that. And as you can see, it is all encrypted. But that's not what we want. So the first step is we need to tell our application that we want to use Always Encrypted. And how can you do that? That is changing, like I said, the driver, but you also need to change your connection string. And what you need to do is the following. you need to add, where is it? Here we go. So you need to add column encryption setting equals enabled. That means you're telling to your application, hey, I want to use Always Encrypted. And that means that we're going to first execute that store procedure. The second parameter that you need to use is the attestation protocol. In this case, again, I'm using VBS enclave, so the attestation protocol equals none, because we're not supporting attestation. If you would use SGX, then it would be MAA, and MAA stands for Microsoft Azure Attestation. And if you have that, then you need to have a third parameter, which is the attestation URL of the attestation. But in this case, I'm not using this. Okay? Cool. So that's the first step. Change your connection string. Now, I'm going to do that. So I'm going to use Always Encrypted. Put that to true. Did I hit save? Try again. Okay. Let's run the application again, because now, yeah, I'm using Always Encrypted. Let's run that again. There we go. And we're hitting the following error message now. So I'm executing a query select count from employees where salary is larger than 50,000. And the message that I get is the following. Data types, money encrypted with encryption type randomized, with that algorithm, with that column encryption key does not match or are incompatible in greater than operators. And the reason why I get this error message is that Always Encrypted requires parameterized queries. So you cannot use literals. So you cannot use, I know, you cannot use literals. So you need to change that into parameters. The reason why we need to do that is, again, because of that first store procedure. If we want to know which columns are encrypted, we need to put that in a parameter. So we cannot use literals for that. So you need to, you need to change that in your code. So if I go down here in my code, so instead of using this select statement, we need to use something like this: salary larger than at a parameter, and social security number like at a parameter. And then you need to define, like below here as well, the parameters itself. That is something you will need to change. I see already that you're frustrated, and that's a frustration of my customers as well. Yeah.
How would you go about, is there a way to, by default, give those connection settings, like the attestation protocol by default, so you don't have to set that in the application connection?
Yeah, you can do that. Yeah. So now I'm doing it here, but that's for demo purposes. I just added dynamically in the connection string. But of course, you can do that fixed. Yeah, but you can just change the connection string as well. Yeah. The question was, by the way, if you can change it fixed in your connection string, these column encryption setting parameter. So yes, you can do that. Okay, so let's change my application, and I'm going to use, instead of literals, parameterized queries. I find this a difficult word, parameterized. But okay. So let's use parameters now. Hit save and run this again. So now it should be good, right? I have my connection string upgraded, and I have my parameters. Nope, I'm getting another error message here. And the reason here is unable to verify column master key signature, invalid key store provider, Azure Key Vault. So my application doesn't know where to find my key vault. I still need to get that information. So you need to register your key vault inside your application. That is done here below with, we've created a function here, and it's done with the new SQL column encryption Azure Key Vault provider. So you get that information when you log into Azure, and you just need to register its insight in your application. So that's the third step that you will need to do if you're using Always Encrypted, if you're using, Key Vault for storing your keys. So if I change this to true, meaning, okay, I'm also going to register my Key Vault now. And let's run again. Let's see what happens now. Still getting the same error message. Okay, I forgot. Yeah, forgot to hit save. Yes, let's try that again. Okay, there we go. So now finally I can run my query here, and as you can see, I can see plain text in my application, which is good because I have access to the encryption key. Now, if you notice that the time it took to execute this simple query, so it took around 3 seconds just to execute a simple query. But if you look, if you go down, I also can execute store procedures. That only took me 58 milliseconds. So why that huge difference? Well, the first time it needs to fetch a lot of metadata. So it needs to first execute that first stored procedure. It needs to connect to the key vault to get the encryption key. It needs to cache that. So that takes a while. So your first query will always be slow, but then afterwards, since everything is going to be cached, all the other queries will be fast. Okay? All right. Still have some time left. So, to summarize, what have we seen in the application? First of all, if you just try it out of the box, your application will not work. So you need to make sure that your connection string has been upgraded. Like I said, column encryption setting equals enabled. And then you need to also specify your attestation protocol and the enclave attestation URL. And this table here below gives you a nice summary of what is the attestations that we support by version. So for SQL Server 19 and 2022, we only support VBS enclave, so not Intel SGX enclave. And there you can choose between host guarded service attestation or no attestation. It all depends. And then the attestation protocol needs to be HGS or none, depending on the attestation that you're choosing. If you use SQL database and you're using SGX enclaves, then you have to use Microsoft Azure attestation, and then you need to put in your attestation protocol MAA from Microsoft Azure attestation. If you use VBS enclaves, like I did in my demo, then we do not support attestation, and then you need to specify none. If you specify none, you don't need to specify enclave attestation URL. Otherwise, you need to do that. Okay? Cool. Secondly, when you run your application again, you will hit that error message that you need to register or that your application cannot find that key vault. So you need to do this on startup, and it allows you, the client application, to access the column master keys in the key vault, right? So you can do this by using the default Azure credential to register the key vault with Always Encrypted. But my colleague Michael, he tested that extensively, and by using that, it took for him a lot of time because he was part of lots of subscriptions. So if you know that your account is member of lots of subscriptions, what we recommend is not to use then default Azure credential, but use managed identity credential or Azure CLI credential. Is there a question?
There's a question online. Didn't you show earlier that with Always Encrypted, no like or larger, smaller is not possible?
So the question is, if I showed that like and larger than, smaller than is not possible. That is correct in Always Encrypted, so the first version. If you use Always Encrypted with enclaves, the version that I have used in the demo and also in the application, then it is possible to do rich confidential queries, and you can use them larger than, smaller than, whatever. Okay? So that was the second step. You need to register your key vault. Then your first query will not work. As I explained, you will need to use parameterized queries. Otherwise, it will not work because the driver must know which fields are encrypted before it can send your queries to the server. So you have to use parameterized queries. Same in Management Studio. If you just want to do simple queries, you cannot use literals. You always need to do declare parameter and then use that parameter in your queries. Literals is not supported. Yeah. Also, what I've showed you in the first query, it was significantly slower than the other queries. And the reason because of that is that your client driver, it first must get all that metadata, it needs to authenticate to the key vault, and then it needs to start getting the encryption keys and unwrapping them, so that takes a while, right? Now, as soon as all that has been done, all the other queries will run much, much faster. Yeah, probably a lot of developers are using, well, not probably, a lot of developers are also using Entity Framework. So Always Encrypted is supported in Entity Framework, which means that my colleague Michael also tested this, and for example, this variables here, they become parameters when you use Always Encrypted. So Entity Framework is supported for that. All right, to wrap up, what have we seen? So I've started with explaining Always Encrypted, the difference between Always Encrypted and enclaves, and then I also showed you what could break in your code. Some resources to give you if you don't know what to do over the weekend. So we have a blog post that explains everything about Always Encrypted with secure enclaves. Our documentation is really big, so go over there if you want to know more specifically. We have a tutorial or multiple tutorials, and that is used a lot by our customers if they want to get started with it. So then it's really describing step by step what you need to do, how you need to configure your keys and stuff like that. So really interesting to go have a look. Data Exposed, that is a channel that we have in the Azure SQL PM team. So we've recorded an episode with me and Anna Hoffman that is explaining also Always Encrypted with secure enclaves. I don't know if you guys know, but there is also an Azure Security podcast that my colleague is hosting, and we've also have an episode there on Always Encrypted. And the sample code that I've used will become online. My apologies, it's not yet there. So I will put it on GitHub so that you can also use it and for testing purposes as well. The other demo application with that website is already on GitHub. So it's under the SQL Server samples repository, and there you can find the same application, the same code, how you can set it up. Okay? That's it. I'm done talking. I don't know if there are any further questions. Yes, sir. So the question was sorry, what was it again? Yeah. Yeah, if you're using connection pooling, if the information will be pre-cached, and that's the case, yes. Okay. Any further questions?
There was only one question from online because some people came in quite late.
Yeah.
Will the slides be available somewhere?
Yes, I will upload the slides to the Sessionize, and there you can download these slides for sure. Yeah. All right. Please do give me feedback. I want to learn if you liked it. If you didn't like it, let me know. If you liked it, let me also know. And enjoy the rest of the day and the weekend. Thanks for joining.